Standard 3.3 means I can apply Newton's second law to determine acceleration, net force, or mass of an object, including a weight to mass and vice versa. So the problem says a box is sliding to the right and accelerating at 3 meters per second squared. An applied force of 15 newtons to the right, as well as a friction force of 3 newtons, is acting on the box. Calculate the mass of the box. So the first thing we need to know is that if this problem is assessing Newton's second law, we should know what Newton's second law is. So Newton's second law is F is equal to AM. Now, in order to solve the problem, we want to list our variables. Let's start with what we're seeing in the problem. We see that something's accelerating at 3 meters per second squared. We have an applied force of 15 newtons. We have a friction force of 3 newtons. Let's list these variables. A is for acceleration at 3 meters per second squared. We have a force that's applied of 15 newtons to the right. We have a force of friction that's 3 newtons. If the box is moving to the right, and we know that because it says that it's sliding to the right, that means our friction force is in the opposite direction that it's sliding. That puts our force to the left. If we were to draw a free body diagram for this box, we would have a box with a forward force of 15 newtons and a backwards force of 3 newtons. Now, in order to use force is equal to acceleration times mass, we're clearly missing a mass. That's what the problem wants us to solve for. So the first thing we should do is rearrange our equation to do that. Let's list our equation. F is equal to AM. If I want to solve for M, I need to divide each side of this by A. I get F over A is equal to M. Now on the left-hand side over here, I have listed an applied force and a friction force. My equation for Newton's second law says that my F needs to be a net force. If I look back at the initial picture, my net force, or my forces on my box, I have 15 to the right and 3 to the left. That leaves me with an F net of 12 newtons. That's taking 15 to the right and subtracting the 3 that are having the box go left, or are the forces that are acting in the backwards direction of the movement. Now, this F net is the number I want to plug in to solve for my mass. So let's do that. 12 newtons divided by 3 meters per second squared is equal to M. M is equal to 4. Remember that our masses always come in kilograms. Now that I've solved for my kilograms, I can solve the second part of the problem. The second part of the problem asks for weight. W equals mg is our equation for weight. We're looking for weight. We solve for a mass of 4 kilograms, and we know that gravity is 9.8 meters per second squared. So W is equal to 4 kilograms times 9.8 meters per second squared. W is equal to 39.2, and remember that our unit for weight is newtons because weight is a force.